We all know that there are many branches of engineering: mechanical engineering, civil engineering, chemical engineering, petroleum engineering, mining engineering, electrical engineering, mechatronics, and many more. Despite many branches of engineering, the governing laws of all those engineering is only one, namely conservation laws. In ancient Greek philosophy, there are two opposite views about the nature of physical phenomena, namely discrete and continuum. Aristotle was the representative of the continuous theory, and Democritus was the representative of the discrete or atomistic one. Despite there are quantitative challenge to the continuous nature of the reality from Robert Boyle, John Dalton, and Ludwig Boltzmann's development of statistical mechanics during the late 19th century, the continuous hypothesis dominated the science. However, at the starting of the 20th century, the field of continuum mechanics and discrete particle dynamics evolved separately because of Einstein's atomistic explanation for Brownian motion and Rutherford scattering experiments. Fluid mechanics. Fluid mechanics describes the motion of fluids and the related phenomena at macroscopic scale, which assumes that a fluid can be regarded as a continuous medium and that their properties vary evenly throughout. Although we all know that very well that fluids are made up of molecules which are in random motion, fluids are viewed at macroscopic scale in which any small fluid element actually still contains many molecules. We can now define velocity, density at any point in that continuous medium in an average sense. This is an average of velocities of the molecules that pass through a small volume surrounding the point. The size of the small volume has to meet with certain criteria. It must be smaller than the physical dimensions of the region under consideration. This physical region can be a wing of an aircraft or a pipe of a hydraulic system. At the same time, it must be sufficiently large to accommodate a large number of molecules to make any averaging meaningful. It seems that there is a lower limit to the size of this volume. For example, when we deal with the displacement of some fluid particle, we do mean not the displacement of an individual molecule. Instead, we mean the displacement of a volume element containing many molecules, though still regarded as a point in the space. This is the reason we consider fluid mechanics as a branch of continuum mechanics, which models matter from a macroscopic viewpoint without using the information that it is made up out of molecules, that is called as microscopic viewpoint. Continuum mechanics are governed by the law of conservations, which states that the total amount of energy, mass, and linear momentum in a closed system remains constant. And that the energy and the mass of the closed system can neither be created nor destroyed. They may change forms but cannot disappear.